Today we're going to talk to you about the production of a standard Coke bottle and any other variants you can think of, including Pepsi. So I'm going to talk to you about the main body of the bottle. It's made using a technique called blow moulding, but for a Coke bottle they often use variations called injection blow moulding, injection stretch blow moulding. All types of blow moulding have very similar pros and cons. The pros include things like it's very, very rapid. Like in some cases they can produce millions of units a day. It's also incredibly cheap per unit because you can produce so many, and there's very little waste, as all the plastic can be put back through the system if it's lost. Means that it's incredibly cheap per unit, which is what people like Coke want from something like this. The main problems with it though are the high initial costs, because tooling is incredibly expensive for the moulds, and any extra bits, like for instance that you've got the Coke writing on the bottle which you can feel, that's going to cost extra because that's extra tooling and extra work. The main materials used include PET, PVC, polypropylene and various others can be used. The reason that Coke bottles use injection blow moulding is because it creates a much better quality thread on the top of the bottle. This means it's less likely to shear off, and it means you're less likely to lose the fizz from the drink, both of which would cause huge problems for Coke if they were to happen. The process is reasonably simple. A preform is made in the injection moulder. This model is a very basic representation of the injection mould for the preform. As you can see when I pull it apart, the preform is a very basic shape. It resembles very much a test tube, and it's modelled around a core which allows the air to be fed in to expand it out. You can tell it's injection moulded because you do get slight split lines. You also get the bit on the bottom which is where it would have been chopped off the sprue. This bit is then put into a new mould which is bigger than the original. Air is forced into it while it's still warm, which it causes the plastic to be pushed out against the new mould. This is what creates the hollow shape with these bottles. Once cool, the mould can then be opened, the bottle is removed and taken off the core. It can then be sent along the production line so it can be made ready for sale. The biggest benefit of these, as I mentioned earlier, is the lack of waste. Because you're using plastics which are, like PET, are very recyclable and the widest recycled material, it means you can basically just throw it back in and get throw in the sprues and all that back through again once they're ground down, and it gets reused in the system.
Injection moulding starts by plastic granules being fed through a hopper into a machine which is then pushed along with a steel chamber heated with metal screws constantly spinning. As the granules come through the chamber, it's slightly heated all the way to the point where it is liquid. Once it's reached the edge and needs to go into the mould, the screw pulls back and allows the liquid to go in, but once full, the hydraulic ram slams it shut and all you have is a mould. But within the mould, before it is injected, it's slightly warmed, so it increases the time of solidification. Then, after a couple of minutes, the mould is simply opened and drops it.
This is a classic Coke bottle plastic lid, which is injection moulded. As you can see on the top right in the middle is a mark where the injection is then fed through and then cut off. This is why it is slightly rough. On the bottom and the inside you can slightly see, only very faintly, a split line where must be where the two moulds have come together, very briefly. As well as that, there's a slight bit of warping on the top of the bottom of the side, where the injection is happening is very hot as it goes in and simply just making the plastic less smooth. Throughout the sides and inside, obviously there's marks, so with the mould it would be indented in some sides so it would stop the liquid from flowing into that region, and then probably through the middle is a water system to cool it off as quick as it can so it can reduce the amount of time needed in between each bottle cap.
The final process in the making of the bottle, which is the label. The label is printed out using flexographic prints, which is a very cheap, quick and easy way to produce very high quality finished labels. Basically it's just plastic sheet, which plastics can be low, medium, high density polyethylene, polypropylene, polyester, nylon and polyvinyl. It's run through a series of rollers all with a different colour on them. These rollers have prints around them, so they've got moulds around them with one colour on each. Most flexographic prints have up to about 10 rollers, so you can get up to 10 different colours. One roller per colour. So as you can see, there'll be one for the green, there'll be one for the most of the purple and the red and the grey and everything. Flexographic prints are a very easy way to produce labels. They print about 350 feet per minute, which equals out about 4 miles of print an hour, which makes it very quick as well. After it's been printed, then it is sent through a calendaring process where this label will be run through another series of rollers, but these ones will be ribbed. This will be to squash it and give it a nice polished finish, which you can see here.